Hello everyone, in this video, I'm going to explain and show why direction finding or radio direction finding absolutely proves that yours is fluxed.
DF. Radio direction finding, RDF, or radiogoniometry is the use of radio waves to determine the direction to a radio source. The source may be a cooperating radio transmitter, or may be an inadvertent source, a naturally occurring radio source, or an illicit or enemy system. Radio direction finding differs from radar in that only the direction is determined by any one receiver. A radar system usually also gives a distance to the object of interest as well as direction. By triangulation, the location of a radio source can be determined by measuring its direction from two or more locations. Radio direction finding is used in radio navigation for ships and aircraft, to locate emergency transmitters for search and rescue, for tracking wildlife, and to locate illegal or interfering transmitters. During the Second World War, radio direction finding was used by both sides to locate and direct aircraft, surface ships, and submarines.
And to be more precise, you are measuring the angle of arrival, which is a bearing, of a radio signal in order to locate its source. So you need at least two separate stations, and each station draws a straight line which will represent the azimuth toward the prism's source. And the intersection of the line will be the position as a transmitter, as shown in the diagram. And now I'm going to show two examples. One example where an operator is in a known position. If we use his receiver, measures a bearing to a transmitter and plot line. And I will show another example where an operator does the inverse, trino transmitter, and it triangulates his own position. And you will see that the result is kinda accurate.
And read your azimuth here.
So now we understand how to find our null. Let's put the bearing on a map. In this exercise, we will know our location and the signal received is unknown. First, we'll orient our map and compass north. Then we're going to line up our base plate with our known location on the map and orient the base plate of the compass with the signal null bearing by rotating the bezel and boxing our needle. Forward bearing in this example is on top and the back bearing is 180 degrees opposite. Now let's say we're using a compass such as this where we can only see our forward bearing marked here with our lubber line. What we would end up having to do is if the bearing observed was greater than 180 degrees, we would subtract 180 degrees to get our back bearing. And if our forward observed bearing, like in this example here, was less than 180, we would add 180 degrees to it to establish our back bearing. And to follow this radio bearing, proceed forward on the bearing, keeping your needle boxed and keeping the signal nulled.
Now for our second exercise, let's say we do not know our location, but we have received an AM station that has identified itself as being in Gainesville, Florida. So it's the exact opposite as our last exercise, and here's Gainesville. The signal null is on a bearing of 102 degrees from our location. 102 degrees is our forward bearing from our unknown location to our identified signal. 102 is less than 180, so we would add 180, giving us a bearing of 282 degrees from the Gainesville station to our current location. So let's work this out. Take our compass, open it up, line it up north, and then what we're going to do. And then we're going to orient our map and compass here. Now we take our bezel, set it for 282 degrees. Now place it on Gainesville, and then all we have to do is box our needle and then we draw our line. So now let's put it all together. Here's our original line from Gainesville. We've also received a station from Live Oak, and that is at 22 degrees. And then one from Perry, which is 315 degrees. So 22 degrees plus 180 is 102 degrees. It'll be 102 degrees from Live Oak. Back to here, we make a line. Then 315 degrees minus 180 gives us 135 degrees. And then we just go ahead and make our other mark. And what we've done is we've triangulated our location. And this spot right here is going to be the area we're in. Now, mind you, this spot right here is the size of a large neighborhood or a small city. And this is the kind of accuracy you can expect from doing something like this with very simple equipment.
There is three main things that completely destroy the globe religion. Let's start with the first one, the azimuth. The azimuth is an horizontal angle. It's the angle between the north vector and an object vector on the horizontal plane. No such thing exists on a globe. The second one is triangulation. Triangulation is the process of determining the location of a point by forming triangles to the point from a known point. It deals with trigonometric function, which use only straight lines references. There is no straight line on a globe. And finally, the third one is that it means that the radio signal transmission is done in a straight line of sight way, which means it's not affected by any curvature and does not follow a curved path that would be needed if we were on a spinning ball.